and we start with data. And data are facts or figures that have meaning. For instance, if I have the figures such as those on your screen, now looking at these figures have no meaning, and one would wonder, what do they mean, represent, or stand for? You must say what they represent. For example, I can say these are marks scored in a mathematics exam. So if I say that, this is now called data. It has meaning. The next thing is information. With the data above, one would ask, how did the students perform? Now you realize again there is little to say about these marks. This is raw data. What I do, I process the above data to give me more insight. For instance, I can say the average score was 55 marks. The highest score was 91 marks. The lowest score was 28 marks. Now what I have done is process the data to get information. I can now have something to report. With an average of 55 marks, I would say the performance was slightly above average. Simply, statistics is information represented in numerical form. The field of statistics deals with data collection, organization, processing, analysis, and presentation. Now, where do we get this data from? There are two sources of data. One is the primary source, and primary sources is data collected firsthand, that is for the first time. On the other hand, secondary data is data that has been collected by others that one wants to use to make some analysis. It may be stored somewhere, for example, archived. Now, data can be collected through observation, questionnaires, interviews, and so on and so on. Once you collect data from the field, you need to record that data. So we use what we call frequency distribution tables. Frequency means the number of times an event or an item occurs. For example, if you record the number of people entering a shopping mall on a particular day, you could have such a table as on your screen. We have the men, we have 12 men who entered, we have 19 women and 11 children. The frequency is the number of each gender, that is 12 for men, 19 for women, and 11 for children. The tally, we use strokes. You can see we group the tally into groups of 5. 4 vertical strokes and 1 that is horizontal. Each stroke represents one person, item, or event. And this is a frequency distribution table, and you can record any data that involves counting. Let us now look at group data, and in the record we had for the mathematics exam, the exact marks for each student was represented. That data was ungrouped. We can now group that kind of data into classes. For example, I can say 5 students scored between 20 and 29 marks, 8 students scored between 30 to 39, and so on and so on. Now this table on your screen shows group data. Looking at that, you can see between 0 and 9 marks there was no student. 5 students scored between 10 and 19. Only 1 student scored between 20 and 29. Up to the last class there, 3 students had a score between 50 and 59. In total we had 17 students. When data is represented in this way, it is said to be grouped. Each group is called a class. The values 0, 9, 10, 19, 20, 29, and so on are called class limits for the respective classes. For example, in the class 10 to 19, 10 is called the lower class limit and 19 is the upper class limit. Grouping of data makes it easy to deal with large amounts of data. All you need to do is choose a class size. You need to choose a convenient number of classes depending on the amount of data that you have. Now we look at data presentation, and once you have collected data, it is necessary to represent it in a visual way. Presentation allows another person to make quick comparisons of various aspects of your data. There are many ways of presenting data, but we are going to look at the common ones. And the first one is a pie chart. And a pie chart is a graph or a diagram, usually a circle with each proportion in the circle representing a given aspect of the data. The proportions are usually sectors of a circle. Each sector subtends an angle at the center that is proportional to the amount of frequency being represented. It is a proportion of 360 degrees, the angular distance of a complete turn. So let's take an illustration, and this table on your screen represents the number of students scoring the respective grades in an English exam. I want to represent this information on a pie chart. Remember, a circle has 360 degrees, so the first thing is to get the total number of students. So we add 4 plus 8 plus 12 plus 4 plus 2, and it gives me 30. So we say 30 students represent 360 degrees. The total number of students represents the total angular distance. Now we find how many degrees each proportion shall represent, and I will start with A. So starting with grade A, I had 4 students. 4 out of 30 times 360 degrees gives me 48 degrees. So A will be represented by a sector subtending an angle of 48 degrees. B, there were 8 students. Out of 30, I multiply by 360, I get 96. C was 12 over 30 times 360, I get 144 degrees. D, 4 students out of 30 times 360 degrees gives me 48. E, 2 students out of 30, I multiply by 360 and I get 24 degrees. Now if you add these angles, they should make 360 degrees. That is 48 plus 96 plus 144 plus 48 plus 24 is actually 360 degrees. Now it's always safe to test this first. The next thing I do is to draw a circle of convenient radius. Now again I will draw a line from the center to anywhere on the circumference of the circle. Let me say I draw that line. I'll then place my protractor at the center of the circle and measure 48 degrees to represent A, the grade A. I measure 48 degrees and I will have that. Now placing my protractor on that line, I want to measure the angle for B, that is 96. So again I will have that line. I place my protractor again on that line at the center, measure for C, that is 144 degrees. D, I will measure 48 degrees. Now I don't need to measure E because the remaining angle is obviously 24. So that is my structure of the circle, the proportional parts representing each grade. Now I can make it more presentable by coloring it like this. And there I have my pie chart. The next type of data presentation is using a bar graph or a bar chart. And the bar chart consists of rectangular bars, each bar representing one item. The height of the bar is proportional to the frequency of the item being represented. Now we shall represent the same information on a bar graph. Now in this case we shall not need to calculate the angles. So the width of the bar is also equal. Now to represent this information on a bar graph, we first draw the vertical and the horizontal axis. So there I have them. My vertical axis will represent the number of students, and my horizontal one, that is the x-axis, will represent the grades. So the scale that I have chosen is that 1 unit will represent 2 students. So I have that scale on the vertical axis. The horizontal one, the bars will be uniform. So after I choose my scale, I then start representing the information. So to represent this information on a bar graph, I will have for A, there were 4 students, so I have the bar for A. It has 4 students. Again for B, I have how many? 8 students. I have that bar for B up to 8. C, I have how many students? 12. So I have that bar for C. D, there were 4, just like A. So I have that bar for D. And finally E, there were 2 students. Now you must always give your graph a title, label the axis and state the scale. Now with my bar graph there, I could give it a title like a bar graph representing the number of students scoring respective grades in an English exam. So my scale on the y-axis is that 1 unit represents 2 students. 1 unit represents 2 students. Maybe on your graph paper you can say 1 centimeter represents 2 students. On the x-axis, the bars are the same. You can say 1 centimeter represents 1 grade. Now the bars need not be vertical, and you can have them horizontal like this. Now unless required, it is always easier to draw vertical bars. The next method of data presentation is use of what is called a histogram. Now look at this group data on your screen on this frequency table. It shows the number of students scoring the respective marks. It is group data. Now I want to introduce something called class boundaries. And literally speaking, to get a class boundary, we take the lower limit in a class and subtract 0.5. The lower limit we subtract 0.5. For the upper limit we add 0.5. For the lower limit we subtract. For the upper limit we add 0.5. For example, in the class of 30 to 39, the lower class boundary will be 29.5. We have subtracted 0.5. The upper class boundary shall be 39.5. We have added 0.5. For the class of 40 to 49, lower class boundary is 39.5 after subtracting 0.5. The upper boundary is 49.5. We have added 0.5. The difference between the upper and the lower boundaries is called the class interval, class width, or class size. That is to say, class interval is equal to the upper class boundary minus the lower class boundary. For example, in our case, for the class of 30 to 39, the class interval is 39.5 minus 29.5, which gives us 10. Having said that, a histogram is a bar graph drawn on a continuous scale without gaps. The area of each block is proportional to the class frequency. The height of the bar is obtained by F over W, which is called the frequency density, where F is frequency and W is the class width. We shall now use the class boundaries in our table. So our width was 10. So we'll have the table as shown here, and then we introduce the frequency density. So the class size was 10. So frequency is the number of students in this case. For example, on the first class, 3 over 10 should give us a frequency density of 0.3. Next is 8 over 10 giving us 0.8, and so on up to the last one. 10 over 10 is 1. So we now draw a histogram. the frequency density versus the class boundaries. So the frequency density is on the vertical axis and the class boundaries are on the horizontal axis. So we have our first bar from 29.5 to 39.5. We have a frequency density of 0.3. Now where that class ends, it means the next one begins, because you realize the upper class boundary of the first class becomes the lower class boundary of the next class. For example, in the first two classes, 39.5 is the upper class boundary for the first class, and the same 39.5 is the lower class boundary of the second class. So the bar will be continuous, there will be no gap. So for the class 39.5 to 49.5, the frequency density is 0.8. The next class 49.5 to 39.5, the frequency density is 1.5. Moving on, 59.5 to 69.5 is 0.6, we have that bar. From 69.5 to 79.5 we have 0.8, and the last class we have 1 up to 89.5. So there you have your histogram. Now notice that the graph didn't begin at point 0. Why? Because this will be a misrepresentation of fact. We start from 29.5. The graph there indicates that it doesn't begin from 0. Now, except for the starting point, this histogram appears just like a bar graph. From that histogram, the bars have equal width, and this is because our class intervals were constant at 10 for each of them. Now it doesn't always have to be like that. There are instances when the class intervals may vary. Now that would mean the bars would be having varying width. For example, consider this frequency distribution table. We have classes there. For example, for the first class is 5 to 9, next is 10 to 14, 15 to 19. Now from the fourth class you realize we are moving from 20 to 34. So obviously the class boundary there is 15. The first three were 5, and then we move from 35 to 44, and that should be an interval of 10. The last one, 45 to 50, we have an interval of 5 there. So you can imagine the bars must have different widths. Now we obtain the frequency density by dividing the frequency over the class size. So for the first class, the interval is 5, frequency is 2, and the frequency density is 0.4. The second class, we have an interval of 5 again, frequency is 4, and 4 over 5 is 0.8, that is the frequency density. Third class, the interval is again 5, frequency density is 1.2. Fourth class, from 19.5 to 34.5, that is an interval of 15. Frequency is 8. 8 over 15 is 0.53. The fifth class, we have an interval of 10. Frequency density becomes 8 over 10, which gives us 0.8. The last class, the interval is 5. Frequency density is 2 over 5, which gives us 0.4. From here we proceed and plot that graph. We first plot the XY axis, we have them there. The vertical axis representing the frequency density and the horizontal one representing the classes. So again the graph will not start from 0. Choose an appropriate width of your bar, but remember the bars will not have a uniform width. Now common sense has it that the class with interval of 15 is 3 times as wide as the class interval of 5. This should and must be reflected in your graph. So for the first bar, 4.5 to 9.5, that is an interval of 5 and the frequency density is 0.4. So there we have that. Next, we have a bar of equal width as the first one. 9.5 to 14.5 again is a difference of 5, so the bar has the same width. Frequency density 0.8, we have it there. The third one again has an interval of 5, same width, with frequency density of 1.2. Next, we have the class between 20.5 to 34.5. That is an interval of 15. Now that will be 3 times as wide as the first 3. So there we have the bar and the frequency density is 0.8. The next one is 34.5 to 44.5, an interval of 10. That is twice as wide as the first 3 bars. So we will have it there, and the frequency density was 0.53. Finally, we have 44.5 to 49.5, an interval of 5. The width of that bar is the same as the first one, and the frequency density is 0.4. So there we have completed our histogram. The next type of data presentation is use of frequency polygons, and this is a graph in which the frequency densities are plotted against the class midpoint. A class midpoint is given by the upper plus the lower class boundaries divided by 2. In the class of 30 to 39, we shall have midpoint is 30 plus 39 over 2, which gives us 34.5. Now you need not to worry, you can also use the class boundaries, you don't have to use the class limits. The answer will still be the same. For example, in the same class, the class boundaries are 29.5 and 39.5. So we have 29.5 plus 39.5 divided by 2, giving us the same 34.5. So let's use our previous example to illustrate. So we have that table there, we have the number of marks in those groups, and then we have the number of students, which is the frequency. We then have frequency densities, and then we have the midpoint. We have already calculated that. So to plot that, we first draw the XY axis and label the axis. We then choose the appropriate scale. Again, this will not start from 0 because the first class is 30 to 39. So the first midpoint is at point 34.5, so it doesn't begin from 0. So what I do for the first class, the midpoint is 34.5. What is the corresponding frequency density is 0.3, so I mark that. The next class, the midpoint is 44.5. Frequency density is 0.8. Again, I have that. 54.5, the frequency density is 1.5. I mark that. 64.5 is 0.6. I mark that corresponding point. 74.5 is 0.8. Again, I have that. 84.5 is 1. I mark that. So I have those dots representing the respective position. Now all I need to do to complete my polygon is to join those points. There I have my frequency polygon. You can see I have plotted the frequency densities against the midpoints of the respective classes. Lastly, I have the line graph. And the line graph shows data that is continuous in trend. For instance, I can have a graph of temperature against time for a certain day. There I have my table first. For me to get a line graph for this information, the first thing I need to do is to draw the two axes, X and Y. I draw the temperature on the vertical axis, use an appropriate scale there. That is 1 unit to represent 2 degrees Celsius, so I'll have that. On the x-axis I have time in minutes, and my scale will be 1 unit to represent 2 minutes, so I have it there. So from the table, after 2 minutes, the temperature is 4 degrees Celsius. I mark that. 4 minutes is 8 degrees Celsius. I have that. 6 minutes is 10. 8 minutes, I have 14. 10 minutes, I have 20. Same for 12, temperature remained constant. At 14 minutes, I have 19, it dropped a bit. At 16, it dropped further to 18. And after 18 minutes, the temperature was 15 degrees Celsius. So I have those dots representing that. And all I need to do to complete my line graph is to join all those points. So there I have my line graph. I give it a title and I give it a scale. Now it is important to know which variable to place on which axis. Conventionally, the independent variable is plotted on the x-axis and the dependent variable on the y-axis. Temperature changes with time, so temperature is dependent on time. Time is independent, it does not depend on any other factor.
The way we teach it in university and in high school as well, and colleges, is if you fall behind, you're in desperate trouble. That if you miss a class or miss an idea or don't do your homework, you go to the next class and the teacher assumes you know it, but it's like Greek to you. And so the biggest challenge is not falling behind, and the strategy is do whatever needs to be done so you don't fall behind. Seek help wherever you can find it, from students, from student help centers, from the teacher, from the teaching assistant, wherever you can get it. Because if you fall behind, it's like you're missing a floor in the building, you're missing a brick in the wall, and you just can't build the second floor without a good understanding of the first floor.